Problem 3. Let f be the continuous function defined on -4 to 3 whose graph consisting of 3 line segments and a semicircle centered at the origin is given above. Let g be the function given by g of x is equal to the integral from 1 to x of f of t dt. Right before I do this, we usually like to write something up here, so I'm going to as well. G of x is going to be, since it's an integral, it's going to be the area under the curve. And then g prime is actually going to be, when we take the derivative of an integral, we'll just end up with f, which is actually just the curve. And then g double prime will be f prime, or the slopes. So just to clarify that as we're working through. All right, this first part is asking us to find g of 2 and g of -2. So first of all, to find g of 2, we're going to find the integral from 1 to 2 of f, and if I look at that going from 1 to 2, it's just this itty-bitty triangle right here. So it is going to equal 1/2 times the base, which is 1, times the height. To get this height, since 2 is halfway in between 1 and 3, then 1/2 is halfway in between 0 and 1, so it'll be times 1/2. That will give us 1/4, but since this area is below the x-axis, it will be -1/4. And then g of -2, we'll be finding the area under the curve from 1 to -2 of f. Well, we're not allowed to do that, so it's going to be the opposite of going from -2 to 1 of f. So -2 to 1 is going to be a triangle and then a half circle. So this is going to equal, the triangle is going to be 1/2, the base is 1, the height is 3, and then plus the area of the half circle, which is going to be 1/2 pi times the radius squared, and the radius is 1, so it'll be times 1. This will be negative because that area is below the x-axis. And then if I work that out, I'm going to get 3/2 minus pi over 2. And that would have been worth 2 points, 1 point for g of 2 and 1 point for g of -2. All right, part B. For each of g prime of -3 and g double prime of -3, find the value or state that it does not exist. So g prime of -3, I wrote on my previous page that g prime is equal to f of -3. So all I need to do is look up the f graph at -3. And once again, they did not give it to me, but since -3 is halfway in between -4 and -2, 2 is going to be halfway in between 1 and 3. So this value will be 2. And then g double prime of -3 is equivalent to f prime of -3. And if I'm looking at f prime will be the slope, so I need the slope at -3. So I am going to find the slope between those 2 points, which is going to be 3 minus 1 over -2 minus -4, which gives me 2 over 2, which is 1. Okay, and once again, we get 2 points, 1 for the first value, 1 for the second value. Right, next one, C. Find the x-coordinate of each point at which the graph of g has a horizontal tangent line. For each of these points, so I'm going to, step 1, for each of these points, determine whether g has a relative minimum, relative maximum, or neither, and justify your answer. So 3 things that I have to do. Okay, so first of all, we have to find where g has a horizontal tangent line. If g has a horizontal tangent line, g prime would equal 0. So I'm going to write where does g prime equal 0? And that is going to be at where f is equal to 0. So those two values are going to be at x equals -1 and x equals 1. So I found those x-coordinates. The next thing I need to do is decide whether they are minimums or maximums. So I'm going to make myself a g prime chart, which we just get to look at f, and I'll be looking at above and below. So we are above the x-axis till I get to -1, and then we are below the x-axis till I get to 1, and then we are still below after 1. So when I'm asking for at each of those values, so I need to state at x equals -1, there is a relative max, and that is because g prime changes from positive to negative. And then at x equals 1, it would be neither, and I would just say because g prime doesn't change sign at all. Okay, that part of the problem would be worth, we'd get 1 point for finding where, oh, just considering g prime equaling 0, so I got to put a point just for putting g prime equals 0. I get 1 point for x equals -1 and 1, and then I get 1 point for saying if they're relative min or max. So that was worth 3 points. And then for part D, for the interval between -4 and 3, find all values of x for which the graph of g has a point of inflection. Explain your reasoning. So 1, 2. Okay, so G being a point of inflection, I know that I need a G double prime chart, and I know that with G double prime, I'll be looking at the slopes of the lines. So the slopes are positive, or the line is going up till I get to -2, and then the graph is going down all the way till I get to 0, and then the graph is going up until I get to 1, and then it's going down after that. So when it's asking for find all values of x that are points of inflection, each of these values would be points of inflection. So points of inflection occur at x equals -2, at x equals 0, and at x equals 1. And my reasoning would be because G double prime changes sign. And this problem would have been worth 2 points, 1 point for all 3 points, and then 1 point for the correct reasoning.